So I will divide that unsorted array to the mid position. So how do I calculate the mid position of that particular array? It's going to be very efficient when it compares to all other different types of sorting. So I will divide that into two different parts. So I will be getting two sub arrays is what you need to remember. After this, what I will be doing is, guys, I will merge this and then I will merge this. Hello everyone, I welcome all of you to yet another interesting session on searching and sorting. So guys, what do we have in today's session? Yes, we have discussed the concepts called merge sort in the last class, right? Yes, my dear students, I will be explaining that in detail with an example in today's session. So that's all we are trying to discuss in this session. Let's start without wasting much of your time with respect to the merge sort. So basically when I speak about merge sort, the first thing that you need to remember, the principle that we follow in the merge sort is divide and conquer. So what is the meaning of divide and conquer, sir? I will be having an unsorted array. So the first thing that I will be taking is an unsorted array. So I will divide that unsorted array to the mid position. So how do I calculate the mid position of that particular array? So I will be calculating the mid value of that array using the formula lower bound plus upper bound divided by 2. So using this concept, I will be recursively dividing the array, especially the unsorted array. So until I get the separate individual item, what I had in the array is what you need to remember. So that's how I will be performing the merge sort. Let me illustrate that. Before we check the merge sort once again, so let me tell you what exactly the advantages, what exactly the disadvantages that we have, and what is the complexity of merge sort. So let me discuss that first, and then I will show you how exactly the merge sort is happening. So guys, when it comes to the advantage, so merge sort is the most efficient way of sorting the list of arrays is what you need to remember. That's going to be the first advantage. It's going to be very efficient when it compares to all other different types of sorting is what they say. All right, merge sort is always fast, but remember it is worse when you have more number of elements. So that's what you need to remember. And it is also stable. This is going to be the advantages that we have when it comes to the merge sort. But what exactly the disadvantages that we have? So guys, the merge sort's worst case complexity is O(n) log n. That's what you need to remember. So obviously, you just have to understand how many number of times it has to divide if more number of elements we have. That's what you need to remember. All right, so it is not in place. So merge sort are used a lot of memory and uses the extra space. So first I have to take the array, then I have to create the sub array, then I have to create the sub array of that. So n divided by 2, n divided by 4. So guys, just imagine what is the amount of memory that we are using in the merge sort. So huge amount of memory. That's one of the disadvantages that we have when it comes to merge sort. And then, so this is little slow when attempting to sort very large data. When we compare to the different types of sorting, it is little time taking. So it is little slow is what you need to remember. That's going to be one more advantage when it comes to the merge sort. So let me understand how exactly merge sort is happening. So guys, this is what you need to observe here. This is a beautiful array that I have taken, which is unsorted. Unsorted in the sense you can't expect the elements to be in a sorted order is what you need to remember. So fine. After that, I will calculate the mid value for this array. So basically I have 1, 2, 3, 4, 5, 6, 7, 8. So I will divide that into two different parts. So I will be getting two sub arrays is what you need to remember, which has got 4 elements in each sub array. So I will divide this into two different array. So fine, after dividing that, again I will divide that into 2. So observe, so this was the first one, and then again I have divided into two different parts. Again I have divided this into two different parts is what you need to remember. So fine, after this, so I will divide this again into two different parts. Observe, so this was the first one which I had 14 and 33. Again I have divided that into separate individual elements. So finally in the last state, so I have separated the individual elements. So after this, what is that I have to do? So guys, I will start the comparison between these two elements. What is that I will do? I will start the comparison between these two elements is what you need to remember. So 14 is lesser than 33. So I will keep it same. And 27 is lesser than 10. Is it true? No. So I will swap it here. I will show that in the next slide. So 35 is greater than 19, right? So I will swap it again. So 42 is less than 44, correct? So I will keep it as it is. So like this, I will swap. I'll perform the swapping and I will keep it. So the lesser amount in the left side and the greater value in the right side is what you need to remember. So after that, so I will get this type of array. Observe here. So 14 and 33. So observe here, 14 and 33. So observe here, the swap has to happen. So after performing the swap, so I've got the value like this. And then observe here 19 and 35. So what I had, 35 and 19, I have swapped it. So I have bought this 19 this side, 13 this side is what you need to remember. All right. So, and I have 42 and 44. So when you compare these two, the left side, what we have is a lesser amount than what we have in the right side is what you need to remember. So fine. After this, what I will be doing is, guys, I will merge this and then I will merge this. So that's what you need to remember. So when I merge this, so obviously the lesser amount, what I have 10, then after that I have 14, then 27 and 33. So this will be one part. So I will make this as one part and then I will make this as one part. When you observe this, so all these things, whatever I have here, so it is sorted. So whatever I have here, it's sorted. This part is a sorted part and this part is sorted part. So now I will join this two and I will make the one particular sorted array. So that's what you need to remember when it comes to the merge sort. So this is how we perform the merge sort, my dear students. So this is the technique that we follow to perform the merge sort is what you need to remember. This is the second example that we are taking to understand the concept of merge sort. So with this, let me wind up the session. Thank you.